Let's jump right into this explainer. Today, we're looking at a radical new green technology that's literally built to secure human survival in some of the absolute harshest environments on Earth. So I want you to imagine the sheer panic if a nation, one that relies almost entirely on the ocean for its drinking water, suddenly has its massive desalination facilities attacked. Right? We're talking about a sudden, catastrophic cutoff of the absolute most basic resource for millions of people. It sounds kind of like a dystopian movie, I know, but for certain regions in the world, this is a very real, very pressing geopolitical threat. Take a look at this quote from the source material we're analyzing. Water is the Achilles heel of the Persian Gulf. Think about that. In this incredibly arid region, over 90% of the drinking water is generated by these massive, centralized desalination plants right along the coast. If those giant plants go offline, well, the clock starts ticking immediately for the entire population. Section 1. The water vulnerability. The core problem here really boils down to centralized vulnerability versus decentralized security. You see, traditional desalination plants are massive. They're sitting ducks, prime targets in a conflict, or, a systemic failure. So the necessary shift is moving toward a scattered, decentralized network of independent pods. It's like a giant puzzle. If one piece, or pod, goes down, the rest of the network survives. It completely removes that single point failure. But here's the thing, the threat isn't just explosive, it's chemical. The sources describe this terrifying scenario called black rain. Just imagine a nearby oil refinery is attacked, creating these raging fires. That produces immense clouds of toxic acidic soot that rains down right on the desalination plants. With PM 2.5 levels exceeding a staggering 1,500, this black rain instantly clogs and destroys the delicate reverse osmosis membranes they use in traditional water filters. Just like that, in an instant, a massive centralized plant becomes completely useless. Section 2. The decentralized fortress. Now, the physical hardware for this solution is absolutely fascinating. These are AlloGroove concentrated solar power, or CSP, dishes. And the proposal describes these not just as regular solar panels, but as independent energy snipers deployed out in the field. They essentially act as autonomous survival pods, perfectly designed to keep generating life-saving resources, even in the absolute worst conditions imaginable. When you compare them to massive, traditional mirror arrays, which are known as heliostats, the advantages are striking. Traditional heliostats are highly vulnerable, right? If just one mirror is misaligned, the whole system suffers, but AlloGroove dishes operate completely independently. Plus, while a traditional plant takes years to build, 4 trained technicians can assemble an AlloGroove module in just 120 minutes. That is crazy fast. And to combat that acidic black rain we talked about, the dish can automatically tilt to literally shake off the toxic sludge. No way, right? It's brilliant. Section 3. Harvesting the sun's power. Okay, so the crucial mechanism here operates at a staggering 1,000 degrees Celsius. While traditional systems try to physically filter the water, the AlloGroove dish focuses sunlight to create extreme, highly concentrated heat. At over 1,000 degrees, you aren't just filtering out the black rain, you're literally burning away complex toxins and organic pollutants. That extreme heat basically acts as an ultimate indestructible purifier. Section 4. Storing heat, making water. Let's actually trace the exact journey of a single photon through the AlloGroove system, because it's pretty fascinating. Step 1. The sun hits the highly reflective dish. Step 2. Intense heat is captured right at the focal point. Step 3. That heat is transferred into a molten salt storage system. Moving on to Step 4, that intense thermal energy creates high-pressure steam that turns a turbine. And finally, Step 5, that steam is used to distill and desalinate the seawater. It's an incredibly elegant, closed-loop system. Now, you might be wondering, well, what happens when the sun goes down? That brings us to molten salt storage. Think of this as a massive thermal battery. According to the data, a full utility-scale setup utilizes over 6,200 tons of molten salt, which is obviously enough to rim the glasses of a truly staggering number of margaritas, held at a scorching 600 degrees Celsius. This essentially traps the sun's energy, which allows the steam turbines and desalination modules to run continuously, 24 hours a day, without needing a single drop of fossil fuel. When we compare the massive 3D concept facility to the actual hardware, it reveals a huge strategic advantage. All of that sprawling theoretical infrastructure,
the maze of pipes and tanks you'd normally expect from a massive utility plant. It's all efficiently packed into a compact, transportable module. It is practically the ultimate plug-and-play survival system. And here is an absolutely vital detail. That 560-degree steam, it's also used to generate power. While its primary job is making water, the turbine also kicks out 3.5 kilowatts of stable green electricity per module. In a crisis situation, that isn't just a nice little bonus, it's a lifeline. It provides enough power to run critical communication relays or vital medical gear, right alongside the water supply. A real game changer. Section 5. Surviving extreme conditions. The final purity metric is honestly remarkable. Less than 10 parts per million of total dissolved solids. To put that into perspective for a second, your typical tap water might be around 200 or 300 parts per million. Less than 10 ppm is absolute medical grade purity. And what's wild is that it achieves this entirely through thermal distillation. It completely avoids those fragile reverse osmosis membranes that would just choke on the black rain. To wrap up our analysis today, let's quickly summarize the competitive edge here. We're looking at zero emissions and 100% green energy. It offers a scalable, modular setup, meaning you could deploy one pod for a small outpost or 1,000 for a major city. It uses absolutely no physical filters or added chemicals, and it deploys incredibly rapidly. The proposal frames the whole shebang as a perfectly pitched, strategic, and eco-friendly investment for national security. Which brings us to our final thought. As the world gets more volatile and resources increasingly become targets, will our future survival actually rely on decentralizing our most vital resources? I mean, when a single missile or a cloud of toxic smoke can cripple a centralized grid, perhaps scattering our lifelines using brilliant green tech, like the AlloGroove, is the ultimate key to global geopolitical stability. It's a fascinating concept, for sure, and one that really makes you rethink what critical infrastructure should actually look like. Thanks for joining me for this explainer. We covered a lot today, and I really hope it sparks your curiosity and left you with a lot to think about.